So this is another supplemental section, some algebra skills that we will eventually apply to our geometry, right? Today we're talking about operations with radicals. And a radical, for our purpose, is a square root. Now the general, broad definition of a radical is it could be a square root, it could be a cube root, fourth root, fifth root, any root you want. But for what we're focused on, we're going to deal with square roots only. So I open up the lesson by talking about irrational numbers. And of course, we know that an irrational number is a number whose decimal form is non-terminating, non-repeating, right? And pi is probably the most popular irrational number out there. We're all familiar with pi. The reason that I talk about some irrational numbers here is because certain radicals, like the square root of 2, if you plug the square root of 2 into your calculator, you'd see a decimal that's non-terminating, non-repeating. So we're dealing with some numbers that fall under the classification of irrational numbers. And whenever we go to simplify these irrational numbers, we don't want this decimal form. We want the simplified radical form. And that's something that I'm going to show you how to do today. All right. So we need to talk about a couple key vocabulary terms and before we get into the actual skills of operations with radicals. So the first here is the definition of square roots, and I'm sure we're all familiar with it, but we need to dot our I's and cross our T's, so to speak. The square root of a non-negative number, n, is the positive number that when multiplied by itself gives n. So we have written here the square root of n. N obviously a variable standing for any number you want to plug in there. But the square root of n means what number times itself would equal n, right? And sometimes the square root of a number comes out to be a whole number, and sometimes it doesn't, right? Sometimes that's when we're dealing with the irrational numbers, when it does not come out to be a whole number. All right, the next thing we need to talk about are perfect squares. And you're probably pretty familiar with your perfect squares, but I want to make sure we review them. So a perfect square is a number that is the square of a whole number. So you can see in the examples here, down the left side, I'm taking the square of every natural number, or actually every integer, because we have 0 in there. Right? So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So it's the numbers down the right side here that are our perfect squares. And we need to know our perfect squares. Right? We need to know them very well. Because when we take the square root of a perfect square, that's when we get a whole number. And the last vocab term at the bottom there is radical. The square root of n is a radical. And it includes the radical sign, which is the square root sign, and the radicand. The radicand is the n. It's the number under the square root symbol. All right, so we've dealt with some of the basics here. Now we're ready to actually look into some of these skills. So the first thing we're going to talk about is simplifying square roots. It says factor the radicand so that one of the factors is a perfect square. If a radicand does not have any perfect square factors, the radical cannot be simplified. So we have 3 examples. The first one is the square root of 75. Now, we first recognize that 75 is not a perfect square, right? So we can't just take the square root of it and get a whole number. That's not going to happen. So what we need to do is we need to simplify the square root of 75. We need to factor 75 into 2 numbers, one of which is a perfect square. That's why we need to know our perfect squares so well. Now, 75 can be factored into 25 times 3. And 25 is a perfect square. So I can take the square root of 25 and get a whole number, which is 5. I cannot take the square root of 3. 3 is not a perfect square, and it can't be factored into two numbers, one of which is a perfect square. So the square root of 3 is simplified. Therefore, I have simplified the square root of 75 into 5 square roots of 3. Our second example is the square root of 500. Again, 500 is not a perfect square, so we need to simplify it. We need to factor it into two numbers, one of which is a perfect square. 100 times 5. 100 is a perfect square. We can take the square root of it and get 10. Can we take the square root of 5? No, it's not a perfect square. Can 5 be factored into two numbers, one of which is a perfect square? No, right? So we leave it the square root of 5. The square root of 500 simplifies into 10 square roots of 5. And our last one, the square root of 17. We know 17 is not a perfect square. Does it have a factor that is a perfect square? Nope. It's actually a prime number, right? 17. The only factors are 17 and 1. So this is already simplified. There's nothing for us to do to that. All right, next, multiplying square roots. It says the product of the square roots is the square root of the product of the radicands. All right, 3 examples. The first one is the square root of 2 times the square root of 5. Well, ready? The product of the square roots is the square roots of the product of the radicands. The radicands are 2 and 5, right? Multiply those together, we get 10. Now we have to ask ourselves, is the square root of 10 simplified? And the answer is yes, because 10 doesn't have a perfect square factor. So square root of 10 cannot be simplified. There we go. Square root of 7 times the square root of 7. Okay. So multiply the radicands together, we get the square root of 49. Can the square root of 49 be simplified? Yes, it can. It's a perfect square, right? The square root of 49 is 7. And then our last one, the square root of 6 times the square root of 12. We multiply the radicands, we get the square root of 72. Can the square root of 72 be simplified? The answer is yes. So we factor 72 into 36 times 2. The square root of 36 is 6. We cannot take the square root of 2, so we end up with 6 square roots of 2. Now, you may have thought to factor 72 into 9 times 8, and that would be fine, because 9 is a perfect square, right? So according to our process, we factored 72 into two numbers, one of which is a perfect square. That's good. The square root of 9 is 3, and we have the square root of 8. 8's not a perfect square, right? So we leave it. But what we must recognize here is that 8 has a perfect square factor. So we can simplify it again. Square root of 8 can be written as the square root of 4 times 2. The square root of 4 is 2, so we get 3 times 2 times the square root of 2. And of course, that 3 times 2 gives us our 6 square roots of 2. Now, this is a very important example and given intentionally, because what it now shows us is that we must always be aware whether we have simplified completely. And if we don't choose the greatest perfect square that is a factor, right? That's not the greatest perfect square, but it is a perfect square. If we don't choose the greatest perfect square, we may need to simplify more than once, like we did over here. So get into the habit of always asking yourself, is this simplified completely? All right, let's talk about dividing square roots. It says the quotient of two square roots is the square root of the quotient of the radicands. Very similar to the multiplication process, right? And remember, the quotient is the answer you get when you divide, correct? All right, first example, the square root of 75 divided by the square root of 3. We can think of that as the square root of 75 divided by 3. 75 divided by 3 is 25, so we have the square root of 25. We recognize that 25 is a perfect square, and we can take the square root of it to get 5. Next example, square root of 90 divided by the square root of 2. Well, that's the same as the square root of 90 divided by 2. 90 divided by 2, 45, right? Square root of 45. Now, can that be simplified? What perfect square is a factor of 45? 9, right? 9 times 5 is 45. The square root of 9 is 3. We cannot take the square root of 5, so we leave it as 3 square roots of 5.